Welcome back. In this lecture, we will complete this question. A line with ends A and B and is 15 mm above HP and 10 mm in front of VP, where S and B is 55 mm above HP and the line is inclined at 30 degree to HP. And the distance between the end projectors is 50 mm. And you have to remember this thing. End projectors is for endpoints of apparent line. So in front view, A dash B dash are the end projectors, and in top view, A and B. And this the distance between the end projectors means the horizontal distance between these 2 points. Horizontal, not inclined or not vertical. Only the horizontal distance between the A dash and B dash for front view, and A and B for the top view. Then you have to draw the projection of line, and you have to find out its true length and true inclination with VP, angle created by true line with the VP. So now start with the given condition, and is 15 above HP and 10 in front of VP. So let's start with this question, and is 15 mm above HP and 10 mm in front of VP. Okay, 15 above, 10 in front of VP. So this is A dash and this is A. You can measure the distance. So this is 15 and this one is 10. Just change it to the main drawing section. Okay, this layer. Now, as per the second condition, and B is 15 mm above HP. So B will be 55 mm above this XY line. So just going to create a offset at a distance of 55, the center. Now above HP, above XY. So and B is on this horizontal line, but where right now we don't know. Let's go to the question. And the line is inclined at 30 degree to the HP. So the true line is at 30 degree to HP. We do not have the length, but we do have the endpoint. Endpoint is on this horizontal line. So then this way we can find out the length of true line as well, because we have the angle with HP. But here in this condition, the angle is given, but length is not given. But if you go back to this point, the last point it is given B is 55 mm above HP. So B is somewhere here in this horizontal line, and as per the third condition, as per the later given condition, you know the angle created by the line with HP is 30 degrees. So I'm just going to make it large enough so that it will intersect with this horizontal line, because we know the end point is somewhere. So just going to make it large enough to intersect with this horizontal line. Now you have to make sure this line should be at an angle of 30 degrees. So keep this length as it is, press tab, and angle should be 30 degrees. So now this line is inclined at 30 degree with the HP, and we know the end is on this horizontal line. So this is the point of intersection. So just going to trim this thing. Now this is our end point for the true line, which is noted by V1 dash. Okay, because it is given, already given, and B is 55 mm above HP. So we have created this line at a distance of 55 mm. You can check the length. So distance between these two lines is 55 mm. So now we got, in the question it is only 30 degree, or the angle created by this two line is given, but now we do have the length, finite length, as well as the angle. Okay, now move to the next point. Okay, as per the next condition, the distance in the question it is given, the distance between the end projectors is 50 mm. As we know, end projectors used for the endpoints of apparent line, and in front view the apparent line is A dash B dash, and the end projectors are A dash B dash, and so it is given 50 mm distance between these 2 points. So A dash and B dash are 15 mm apart, and this distance is for horizontal distance, not for vertical or inclined. The horizontal distance between A dash and B dash is 50 mm. Okay, so just going to do one thing, select this thing, make an offset at a distance of 50 mm. Type 50, just enter. So this line going to appear at a distance of 50. You can check this one is at a distance of 50 mm. So now in the question it is given the end effectors of the end effectors. This end effector case is for both conditions, for front view as well as for top view. In front view, we end effectors are A dash and B dash. We're just going to extend this thing because we know our endpoint lies on this horizontal line. So, and the horizontal distance between the A dash and B dash is 50 mm. So, just this point of intersection gives our apparent line. So, this is going to be our apparent line, and this point is B dash. Now, in the front view, we have apparent line as well as true line, and the distance between the end effectors is given. It means in front view A dash, the distance between A dash and B dash is 50 mm. Same thing goes for the top view. The distance between the end effectors in top view. In top view, the end effectors are A and B. So the horizontal distance between A and B is 50. So it means these two B dash and B will lie on the same vertical line as per this current condition. And you know, as the shortcut we always know, end vectors lies on the same vertical line. Here A dash and A are already on the same vertical line. So from here you can see B dash and B. Right now we do not have point B, but later when we find out, it will be on the same vertical line as that of B dash. So next thing is, so these are the given condition. Now we have true line and apparent line in front view. So with these two lines, we have to find out our apparent and true line in top view. Now draw the projection of lines and determine its true length and true inclination with VP. So now what we're gonna do is we're gonna use this apparent line to find out this apparent line in the top. Okay, so I'm just going to remove this thing first. Now we know horizontal distance between the end effectors is 50 mm. So just going to make this a little longer, and we know point B is somewhere in this vertical line for the top view. Now what I'm gonna do is I need to find the end effector, which is point B. After finding this point B, if I connect this is a apparent line, and point of apparent line which will lie on this line. So to find out this apparent line, I'm going to use true line. So what we're gonna do is from here, end point of this true line, going to draw a vertical line. Now from this A, going to draw a horizontal line which will intersect with this vertical line, and now we have to draw an arc which will intersect with this this vertical line, which represent the distance between the end effectors. So just do one thing to create an arc. Use the simplest thing is to draw a circle. So take this A as a center and radius up to this intersection point. Now this arc is intersecting with this vertical line here, so I need this intersection point. So from this, because this point is find out using the true line here, so this is going to be our apparent line. So connect this intersection point with point A. So this is going to be our apparent line. And if you compare this thing with the question, in the question it is given the end effectors A dash B dash, the horizontal distance between these 2 points is 50 mm. So this case goes for this one also. So this is our end effector for top view, and this point is B. So again, that is horizontal distance between these 2 points is 50 mm, and both these points lie on the same vertical line. So this is our apparent line. Now from this point we know endpoint B, and which is the endpoint of apparent line, and B1, which is the endpoint of true line, will lie on the same horizontal line. So with the help of this apparent line, I'm going to draw true line here. So just need to draw a horizontal line from A dash. Now create a circle first from apparent, because we are moving from apparent line to true line, so we need to create an arc first. So take this A dash as a center and radius up to B dash. Now this line is intersecting here. Okay, just going to remove the previous curve first. Trim this arc already been created. Do not need this. Do not need this. And delete this thing. Now what I'm gonna do, create a circle from this point A dash as the center and radius up to B dash, because with the help of apparent line I'm going to draw a true line. So just going to need we just need this line, this curve, and this point of intersection. So remove after this, you can remove the curve after this point. Okay, now from this we have created an arc by taking A dash as a center and radius up to this B dash. Now from this point of intersection, draw a horizontal line, and which will intersect with this horizontal line. Draw a vertical line from this point of intersection, which will intersect with this horizontal line, because we already know the endpoints of true line, endpoint of true line will lie on this horizontal line. So this is our this intersection point is endpoint of true line. Now connect this intersection point with this point A. So this is our true line, apparent line in the top view, and this is true line, apparent line in the front view. So this, in this way, our projection is complete. Now what we have to find is we have to find out the true length and true inclination with VP. So the true inclination with VP is this one. Angle created by true line with VP is 37 degree, and the true inclination with HV is given. So just this is our true inclination with VP. Now we have to find out the true length, and to check whether this question or this projection is correct or not, we are going to, it has already been asked in the question to find out the true length, and to check whether this is correct or not, we can verify with this thing. If true length in both cases, in front view as well as in top view, if both the lengths are same, then this question is correct. So just use this aligned command. Now first point A dash, so true length is 80 for the front view, and it should be same for this top view case. Again true line, so again it is equal. So the true length is 80 in front view as well as in top view, so our question is correct. Okay, so this is a complete projection. Okay, thank you.